Good morning, everybody. Sorry, good evening, everybody. Welcome to ML Ticket, and we are now at the very end of our project. We have almost finished our project. To be honest, now for the next few sessions that we are going to take, these sessions I would say belong to an intermediate level of machine learning code. I'll be still teaching you or showing you stuff that you should not need as a beginner. Okay, you should not need these things as a beginner, but I'll be showing you those things because it is very important for you to know these things. But as a beginner, these are some of the intermediate things that you are going to learn. And some of them are a little bit advanced and things. Okay, so we are going to see some things today. Hope that is interesting enough. So let's get started. Okay, first things first. Yesterday we had a problem with our. It was giving some kind of an error. So I said Jay I could not figure out what it was, but I just reran the code. I closed that window and reran the same code, and it turned out to be fine. Okay, so sometimes these things happen. Yeah, when you are going for machine learning projects, your code doesn't work. Some kind of a error it can happen due to some kind of a RAM problem, or some memory error. Okay, so just rerun the entire code and it will turn out fine. Okay, so today we have a interesting thing to cover, and for that interesting thing I'll be using another small data set. Okay, because you may ask why I can do the why I'm not doing this over the real data set. Because to be honest, I do not want to. We are at the point of the very completion of our project, and to be honest, we are going to apply those changes. Of course we are going to apply those changes. Then otherwise there was no point in telling you this stuff. But I am going to finally apply that set of changes, and since I am going to show you the intermediate steps between them, I do not want to mess with this particular dataset right now. Okay, and since we have completed our training and all, so I don't want to get into that. So I am going to use a small dataset. It is a very famous dataset that I'll be using. So I'll be talking about it after a few seconds, after a few while. First things first, we have to understand that what we are actually trying to achieve and what is the topic of today. Not RNSE. Okay, training accuracy. There are three types of accuracy scores, which can be broadly divided into three types. Broadly divided into two types that are generally used. One is training accuracy. We have seen training accuracy, to be honest. Let me just give you the definition. As we have seen that if we do this, there is a higher chance of overfitting the data, and hence it is not a good measure of good measure of accuracy score. Actually, we have seen this. Let me just show you this once again. You can see this here, J. It is giving me the RMSE score is 0. That our data is absolutely perfect, giving the perfect predictions. Giving the prediction perfectly as form as of the best fit. Okay, so as I said that this is not possible for since we are looking to taking up data from the training data only, and testing our model on our training data. So it is a high chance that it will give 100% correct results. Okay, basically what we have learned, this is what you known as over generalization, or in the terms of machine learning it is known as overfitting. We have been talking about overfitting for the last two sessions, so I don't need to explain that overfitting once more, but if you want you can just go back to those videos and you can understand. We have dedicated an entire video only for overfitting and underfitting. So So the data is overfitting and we can understand it, and this is happening because we are using something which is known as training accuracy. This particular technique of taking up data from training and checking this data is called training accuracy system. Okay, so what is the better approach? A better approach that is mostly used mostly as a beginner, when I first started out, I only used to the I don't didn't use training accuracy. I directly started with testing accuracy because it is the most famous types of accuracy scores to understand, and to be very honest, it is very easy to implement. So let's see. So split the data into two pieces so that we can it can be trained and tested upon different data. Testing accuracy is better estimate than training accuracy out of sample performance, but it provides a. Acha, let me just explain you do these points. Okay, so previously when we started out, we if you remember that we did a train test split. Then we started went for a stratified sampling. If you remember that we have split our data into two parts. One is training data and testing data. And I have said we are going to need that testing data. Now, if I just check the accuracy score of this particular model on the testing data, it will give me a better accuracy measure. But also, it is not the most efficient way to do this thing. Why? Uh, just look at the third point. But it provides a high variance. What is a high variance estimate? You need to understand this high variance estimate. It is a fancy math term, to be honest. I am just going to explain you in layman's term that if you remember, let me just go back to the code. If you remember, I am going to scroll back to the very first of our code when we first did our split. Where is that code? Yeah, just consider this thing. We did a stratified split, of course, but just consider this thing. We selected, I have said there is this attribute named random state. Now, if you change this random state, the combination in which the training and testing set will be divided will be changed. Okay, so the testing accuracy highly depends on this particular random state. How? You may ask how. I'm going to show you that. Okay, so let's not just talk, and let me write the code that will explain what is this problem with testing accuracy, which is known as high variance estimate. Okay, so let me just write the code, then you will understand. Okay, so as I said, I will be using something, another data set, a very small data set, to be honest. This is a very small data set, but it's a very famous data set. If you are using machine learning, if you are learning machine learning for a while, you must come across your this dataset that is known as the iris dataset. It is known as the iris dataset. Okay, very famous dataset for classification problems. But wait, we are doing a regression problem, right? Why I'm taking a classification problem dataset? I'm just giving you an insight into what classification projects look like actually. So just have a look. Okay, you don't need to understand the code right now. Okay, you just need to understand the concept behind it, because some of the code you may not understand, so don't get confused. And this part of the code that I'm writing right now, it is not related to this current project. I am writing this part of the code for you to make you understand what is why we do not go with testing accuracy. What is the problem with our testing accuracy? Okay, let me just import all the libraries that I'll be using. So then we will continue. I have imported this library, but just for instance, I have imported it way up here, up there, and I have to scroll way more. So I don't want to. But okay. Uh, So I'm going to use algorithm which is known as k nearest algorithm, k nearest neighbors classifier. We have, if you remember that, if you remember, we have KNN here. I have said that this is a intermediate level algorithms, and we are not talking about KNN right now. So you don't have to worry about KNN. Okay, you don't have to worry that what this algorithm does, what are the inner functions and all. So don't think about those things. Okay, just concentrate on the thing that I'm trying you to show. I'm showing you something, and just try to understand that particular thing. Okay, I am repeating this one more time, that I do not look at my code right now. If you do not understand it, it does not matter. Okay, so iris, for those people who have never seen iris dataset, I'm just going to show you this. Oh, sorry, it does not come right like this. I think it's an umpire. Yeah. Okay, so um, it contains it is in a NumPy array format. So you just don't need to understand what is this dataset. Just know that this is a very famous dataset that people use. Okay, so actually, what it is, let me just tell you a little bit about iris dataset so that you will understand. It contains data of petal length, sepal length, and like this. And there are three particular target names, or three particular names of the kind of the flower: is Centosa, versicolor, and virginica. Okay, so we have to give those sepal length, petal length as input, and it has to output this particular which category, which type of flower it is. Okay, so it is a classification problem, but here we are dealing with a regression problem. Actually, I chose this particular data set for two reasons: because it is a very small data set. Okay, as you can see, it is a very small data set, and it contains, if I don't remember how many it contains. I think 100 or some data points it contains, 100 or 110, some data points it contains. Okay, so it's a very small data set. That's why I've chosen this. So we don't have to worry much about this thing. It comes, we don't have to do any kind of pre-processing. Not doing anything. Okay, I'm just going to directly feed the data. X-axis is iris.data. It takes up all the sepal length, petal length, that thing. And in the y-axis, we are providing it with the target variable. And what is the target variable? Target variable is this Centosa, virginica. That is what the category that we are using. Okay, we can just get it like this. Now you may ask, Jeva, how am I getting the data using iris.data? It is not possible. You don't need to understand that thing, right? Just listen to my words, that X contains the data points and Y contains those points. Okay, So now we are going to split the data. But you have, but I have always said it is better to use stratified sampling. But okay, we are not going for that right now. We are just going to splitting the data in train test split. If you remember that we have to pass three parameters, x, y, and random state. Let's go with 42. Okay. I am going to make an instance of this particular class. And we are only taking one parameter, that is n neighbors. It's 5. By default, it is 5 only. So we are going to fit the data. And we are going to train it using the training set. knn dot will supply the x test, and now accuracy score is another metric. It works a little differently, but it just gives you the accuracy. Okay, and how accurate your measurements are, with the how accurate your predictions are. Okay, how accurate the predictions are, and how much it is different from the real data. So accuracy score, and we have to pass two parameters, that is y test, that is the real data that we have, and we have to pass the predicted value also, y pred. Okay, so let's just run this thing. Let's see what happens. Okay, dot 1.0. What is 1.0? It comes in decimal points. You have to multiply 100 to get the percentage. So it's 100%, making 100% accurate specify. Okay. Now you may ask, okay, this is completely fine. It is completely understandable. You don't need to understand how the k-n neighbors classifier work. You don't need to understand right now. Just hold on for a minute. I want to explain you the concept that is going on. Again, I am telling you that I am using this data set just because that we have done so many things in our that California housing data set that I don't want to mess with it again. Okay, and it's a small thing to understand. So why we are not doing this? It is giving you an accuracy score of 100%. Okay, that's not a problem. This type of accuracy score generation is known as testing accuracy score. Okay. So what is the problem with it? The problem with it is that if I change the random state, it changes the combination of training set and testing set, right? So let me just change it. Let me just take 4. See, the accuracy changes. Let me just take another thing. Sorry. Oh, sorry. Okay. Let me just take another one. Okay. Let me just take 56. Okay. So the accuracy changes every time. The accuracy changes every time I change the random state. That is the testing accuracy depends on the way, the combination of the attributes chosen in the testing set and the training set. Okay, so it is highly it is not very good idea to do this because if the random state changes, the accuracy score changes. So this is not the way, right? This is not the right metric to use while generating an accuracy score, right? So what is the right metric? So let me get back to my slides. Okay, let me just go through this testing accuracy one more time. So as I said, this particular concept, this thing is known as high variance estimate. Okay, you don't need to understand anything else. This particular thing is known as high variance estimate. Now read through that third point once again. But it provides a high variance estimate since changing changing which observation happened to be in the testing set can significantly change the testing accuracy. We saw that we are changing the random standard and the accuracy is also getting changed because we are changing the observations on which the training and testing sets are divided. So what is the correct metric? The correct metric to do is k-fold cross validation. Now, what is this k-fold cross validation? Let me just go through the algorithm that k-fold cross validation uses. Okay, because it is very crucial for you to understand. It is very easy to understand. You won't find any kind of a problem with this. So let me go through the algorithm first. Split the data into k equal partitions. You have the data set. Okay, split the data set into k partitions. For example, if you have 100 data points, split the data into k equals to 5 equal partitions. So 20, 20, 20, 20. Okay, each partition contains 20 data points. Okay, these partitions are also known as folds. Use one fold as testing set and the union of other folds as training set. Now you have 100 data points, right? Now you are taking one fold, that is one partition which contains 20 data points as testing data, and all the other 80 data points as training data. Okay. Calculate the testing accuracy. Now calculate the testing accuracy on this thing. Now the real thing comes in. Repeat the steps 2 and 3 for k times using the different folds. Now you choose the first fold, right? First fold, first 20 observations, and taking all the 80 observations as training data. Now you from another instance came and you chose the second 20, and all the other 80 become the training data, and those 20 become the testing data. It is a little bit harder for you to understand right now. Let me just show you a diagram. You will understand it better. Okay. So this is the diagram. As you can see, do we have a pen? Yeah, we have a pen. Okay. As you can see that we have this is suppose this is the end. Okay. Oh, sorry. Okay. Oh, these things are very complex to understand sometimes. Okay. So this entire thing is the data set. Okay, and it is now I am taking the first half, taking the first 20 points, and the rest 80 as training data, and we are getting the accuracy score. Next time, taking the next 20 data points and considering all the other 80 data points as training, and we are getting an accuracy score. And if we choose a 5 partition, if we divide our data into 5 partition, it will happen for 5 partitions, and we will get 5 accuracy scores. Okay, so this is the concept. This is the concept behind the k-fold cross validation. Okay, so if you look at the first fifth point, it is use the average testing accuracy as the estimate out of sample accuracy. This is just it means that just find the mean of the 5k of the k values, and you will get what you need. Okay, now let me just show you this thing so that you can understand it better. As I show you, you will understand it better. So everything, all the process that all the steps that we have seen could be done using a single scikit-learn class. Of course, we can do these things. And the library is called cross-val store. Okay. So I am making an instance of the class. Okay, and I'm taking a value scores. We don't need to predict anything. We have to directly can feed the data inside this cross-val score. Okay, so what is this? We can use say cross-val score. We have to first pass the model, then we pass the x and y, then we say CV equals to 10. Okay, what is this CV? CV is the number of folds. Okay, so I am deciding we want to divide the entire dataset into 10 partitions. Okay, so CV is just the number of partitions. Okay, and we have to pass another thing, scoring, and I'm going to give it accuracy. Okay, so you don't need to understand why I'm giving scoring equals to accuracy right here. Just understand this thing. Accuracy is a good parameter to choose, good technique to choose when we are considering a classification problem. Okay, you don't need to get into a depth why I'm choosing accuracy. Okay, so okay, that's all, and we are going to print the scores. Okay, so there you go. So we have 10 values, right? We have a numpy array and it has 10 values. Now, if you can see that when we consider the first half as the testing set and the rest as the training set, it gave me an accuracy of 100%. Then it gave me when we consider the second part as testing and other parts as training, it gave me a accuracy of 93%. Similarly, all these things. Okay, so these are the things that it generated. Now another thing we remember, that the fifth point, that use the average. So we just say scores dot mean. Okay, so we get is accuracies of 96%. So this is a good metric to understand. Now we have a now we can be assured, okay, this is a very good metric to understand our accuracy score. Okay, so though we have got there are it is giving sometimes 94%, sometimes it is giving 100%, sometimes it is giving 86%. So rather than using testing accuracy, we can use cross val score or k-fold cross validation. Okay, now if you go through this algorithm one more time, you will make perfect sense. Split the dataset into k equal partitions, use one fold as testing and union of other folds as the training set, calculate the testing accuracy, repeat steps 2 and 3 for k times using the different folds, use the average of testing accuracy as the estimate out of sample accuracy. Okay, so there are you saw this diagram, so it is very, I think it is very clear for you to understand that how the test cross val score actually works behind the screen. Okay, okay, so let me just continue. There are some recommendations for cross validation that we must keep in mind. K can be, okay, we are missing a space, don't mind that. K can be in a number, but k equals to 10 is generally recommended. That is, we in the scikit-learn library, we have to put CV equals to 10. Why? Now you may ask why it is generally recommended. Now it is generally recommended because people have taken samples and done a lot of things, experiments, and experimentations have shown you that k equals to 10 give the best accuracy, stable and best accuracy scores. So whenever you are trying to do cross validation, just stick that CV equals to 10. Okay, that is a very general approach. For classification problems, stratified sampling is recommended for creating the folds. PS, scikit-learn's cross-val score does this by default. Though our cross validation, it is the cross validation is also splitting our dataset into testing and training set, right? So rather than doing it like a train test split, that is almost randomly, it is a good idea to use stratified sampling. Okay, so whenever we are using cross val score, This thing does it splits the data into testing and training set using stratified sampling only. It is by default. Okay, we don't have to do anything. We don't have to explicitly divide the data and give this to you. But Crosswell score takes care of everything. So it is that easy right nowadays to understand these things. Okay, so another thing, as a beginner I would like you to understand this thing, um, that is how to fine tune your model. Okay, what is fine tuning your model? Now if you go to this classifier, you can see that we have passed a particular, sorry. Okay, if I just tap space, I can see the parameters that it is passed. In neighbors weights, it takes uniform. It takes an algorithm. Okay, so leaf size, p, metric, many things. There are so many parameters and attributes to use from this particular KNN classifier. Okay, similarly for random for decision tree, linear regression, logistic regression, every other uh, uh, algorithms comes with its unique set of parameters, okay, that you can pass, and these parameters actually helps you in fine tuning your model. Okay, so sometimes if we choose n numbers equals to 10, n numbers equals to 10, it gives you a better accuracy score. And sometimes if you give n numbers equals to 2 on some data set, it gives you better accuracy score. These are the thing which is very volatile from it changes from data set to data set. There is no fixed value that ensures that you will have a great accuracy score. So you have to try and go for and trial and error thing. So by using this cross validation, you can actually estimate that what particular parameter to pass, what the particular parameter value to pass. So how is that? Okay, I am just considering one parameter. There are many parameters inside K neighbors classifier. I'm just using K one parameter. Now you may say, I don't understand what is this n neighbors. I don't understand. Just consider there is a parameter and we are passing 5. We are getting a score of 94%. Okay, and we can give any number instead of this 5. Okay, so let me just but what number to choose? You don't know what number to choose whenever you are doing this. So let me just uh, let me see the what number to choose between 1 and 30. Okay, if I am setting a range from 1 to 31, and I am taking a list, Python list, sorry, and okay, and I am going to run a for loop from 1 to 31. And it is just simple for loop, and this is nothing fancy. Sorry, let me just. Okay, and I'm going to do this particular line for 30 times, I guess. What happened? Okay, and instead of 5, I'm going to pass k. So every time the k value increments, I'll be getting a score, and I'll be appending that score, appending the mean of the score. Okay, appending the mean of the score in this particular list. Okay, and I'm going to print this list. Okay, so let's run this. You're getting multiple scores, right? and let's see what happens. Okay, we have a collection of 30 scores. Okay, and it is giving you a large decimal values. To be honest, it is never not possible for us to understand like this, and since our brain cannot understand, uh, we cannot understand our these kind of numbers, so we visualize. Okay, so I am going to draw a line plot. So plt dot plot, x value is the range and y value is the score that we have. Okay, so we here we have it. So the highest score, I guess it attended like 98%, and it attended 98% for something around I think 13, 17 and 20. Okay, other than that, the lowest score that has got is about below 95%. Okay, so now we have an idea. If we choose if we choose this in k in neighbors equals to 20, it may give you a better accuracy score. Okay, so let's just try it out. We should not waste any time, and let me just try it out. Okay. Oh, sorry. 20, right? And I'm going to print the mean. Okay, because mean is that what matters. Okay, we got a 98% score. Previously, we got a score of 96%. Now we have a 98% score. So this I just turned this number from 5 to 20, and it gave me a 2% greater to a score accuracy. Okay, so these things what we are doing is known as the fine tuning model. So if you remember by this time that I have not touched our original data set, the original data set today. Tomorrow we will continue with this cross validation, but tomorrow we will apply cross original data set. And of course, we will be looking at and another technique to fine tune our model. And we will continue this tomorrow. So I don't want to pressurize you because I can do the code right now, but it is a little bit problem for you to understand. There is a lot there are few things, there are few parameters that I need to explain so that you can understand it better. So we will continue from next session. We will again, I am repeating this. I have repeated this for a hello, hello. Is it audible? Okay. So I think I lost my presentation. Sorry, there was a slight network issue. So whatever. Uh, However, we have completed our session today, and we will continue. And I'll be showing you the same thing, this cross validation thing, but on our data set that that on our regression problem that we are doing. And I'll also need to uh, talk about some coding techniques that we are going to use. So stay tuned, and we are almost at the end of our data set, almost at the end of our project. A few more sessions and we will complete it, and let's see what happens. So you can sign off and enjoy the rest of your evening, and Merry Christmas.